And I managed to make really quick lunch. Look at this really quick lunch here. It's just fucking salami and nuts and I don't know, whatever sauce. I think this is the equivalent of what they call like boy dinner. Is that what they call it? You know, like girl dinner is like, I think like wine and cheese or something. Boy dinner is just like meat and nuts and like random dips. Tastes pretty fucking good though. I'm a fan. Anyways, today's Wednesday.
Yeah.
Halfway through the week. What's up, Sensation? Yes. Can you hear me? Can you join the stage, or is something weird happening with the stage? Okay, no, you can't. Sorry. Oh, you are here. Okay, good, cool. I was just making sure because I saw both the other boys join, but they I invited them up, but they're not coming up to say hi yet. Lonely.
God awful Akon song.
I'm so lonely. You know, Akon did a lot of good stuff apparently for the world. Like, I know he made all those. What was that? That song like "Sexy Bitch" and like whatever.
Yo, okay. Hello.
Yo, what's up, Patty? There he goes. There he goes. It works. What's up, dog?
No, cause I switched to my phone. My laptop's bugging right now.
Damn, dude.
Hold on, wait. Give me 1 second.
L laptop, dude. What's up, Equity?
Oh, there we go. Now it's working.
Oh, now your audio quality much better, dude.
Really? Well, that's the phone to the laptop transition. So.
Big fan. What's going on, dude? Did school year start for you?
Yeah, third week.
Damn! Wow, third week. Y'all are in it quick.
Third week,
crazy.
yeah.
That's crazy.
Dude, it's flown by, dude. I've been in college for a month. Doesn't feel like real.
What's your favorite? What's your favorite memory from the first 3 weeks of college?
Favorite first three memories.
Favorite 3 memories you can say from the first 3 weeks that you can say on the stream. You know, like kid friendly.
That I can say legally.
I don't know. You can. I mean, whatever. I'm not gonna get you into trouble if you're underage drinking. It's college, I guess.
But, yeah, it's college. Shit. I mean, dude, I've been meeting so many people every day. Like,
nice.
It's
yes.
It's kind of hard to remember all the names, though.
You meet a lot of different people, too, right? This is the cool thing, because when you're in high school, you're generally only meeting people that are in your neighborhood, right? Or people that you've kind of known or grown up with. College, people come in from all over, dude. And so,
dude, like, I've met some people from California. This one guy is from DC that lives with me. Like, it's insane, yeah.
Nice.
Completely
all different cultures, and like you learn how to interact with them and live with them, which I think is a very, very important just like life skill to learn, because the world is global.
Yeah, it is. Yeah, and especially at U of I, we got 60,000 students, and like
60K?
Probably like a good or like 50, I think it's like 50.
That's a lot. That's still a lot. Man.
It is.
That's a lot of fucking people.
And like, not trying to sound like racist or anything, but like. Half the people I see are like Asian or Indian here.
Yeah. No. I mean,
that's
like,
because it's a top engineering school. So
exactly. No, the same thing was when I went to grad school at UCLA. They used to joke, what was that Childish Gambino song? Asian girls everywhere, UCLA. And like, yeah, it's a lot of Asians at UCLA. But yeah, I mean, that's what happens when you get into certain fields. Certain fields are dominated by different ethnic groups because I guess their parents put a different emphasis on stuff. If you were at basketball camp, I guarantee you all your friends would be black. Like it's just what it is,
I mean, we are a basketball school. Like our basketball team's good.
Nice. Are you at UICI? Sorry,
UIUC.
UIUC. That's
University of Illinois Urbana-Champaign.
Oh, that's a very good engineering college. Oh, congrats, dude. I forgot you got into that school. That's a really good school.
Not for engineering though. So.
Oh, but whatever. What are you doing there? Yeah. Are you going for business or what?
I'm a kinesiology major.
Oh, that's still cool. Yeah, that's science, dude. Ish, right? It has the word ology on it. Ology means science.
Ology means study of. Yep. There you go.
Study of psychology, sociology. I don't know all the ologies. Nice, dude.
Yep. Something like that. Yeah.
Cool. That's good. I'm glad you're having fun, dude. I mean, I keep trying to tell all the kids, that's the whole point of, buckling down, getting good grades in high school and stuff, is that Then you get to go to college. And would you say like college so far has been a lot better than high school?
Oh, I love college. It's way better than high school.
I love college. Yeah, there used to be a song called "I Love College," and then it was like, "I love college, I love drinking, I love women, and I love college." No one knows this song. Demented, do you know this song? I'm gonna go get it.
Sorry to break it to you. No, yeah. I think
No, dude. Dude, I'm generating. I'm aging myself right now, dude. Okay, I'm just gonna post it for you guys.
Insanely.
I can't play it because fucking Twitch will like get mad at me for copyrights.
Very, very quickly you.
It was Asher Roth, dude. This guy was great, dude.
Oh my god.
Man, oh dude, this is so bad. 15 years ago, dude.
15 years ago? God damn.
15 years ago. There we go. Watch it in your free time, guys.
You were old. 15 years ago?
Now, Demented, you started college as well.
3.
You started college as well. You started college? Yeah, nice, dude. Awesome. We got two intro college students. You guys started in my server in high school, and now you're in college.
Yeah.
Yay.
I joined when I was in like grade 9. That was so long ago. I was like freshly out of middle school. Now I'm fresh into college. Time moves fast, I can't lie.
It does, dude. Yeah, it only gets better, dude. It gets great. Yeah, nice.
Oh my god, f of x equals the absolute value of x, dude.
Do you have math classes?
I look back at the help screenshots. I'm like, I wish I had that.
Oh yeah, some of the questions are pretty easy.
I hate my math classes. I hate my math class.
Oh no, guys.
I don't take math.
Calculus. I'm so bad with calculus, bro. The review was like dividing by polynomials and shit. I was like, no.
Yeah, dude. Uh-oh. I mean, I guess. Yeah, I know.
Shit,
well,
I need to go for like 2 minutes.
You're good, Patty. Yeah, come back. You're good, Patty. All right. Yeah, Demented, what's up? So you're taking calculus. Is it calculus 1 or calculus 2? What are you taking?
It's called technical math, but it's technically calculus 1.
It's technical. Sorry, it's called technical math, but it's technically calculus.
Yeah, technically, like under the course code, it's like. Calculus,
and this is so. Remind us, you're in biomedical engineering, or are you looking to transfer next year, or you're in biomedical engineering?
Yeah, currently, yes.
Nice. Okay. So yeah, you do have to take some sort of math classes, definitely some science classes.
Yeah, chemistry, biology, even anatomy. And then brain image scan shit to learn how to use
like fMRIs, MRI stuff. Okay.
Yeah, that shit. It looked pretty
That's
cool.
cool. See, isn't this the cool thing about college is that like no longer it's like I gotta go take PE and history and like you get to take all this like cool shit.
I love it. When I walked into my classroom, I never fell in love with the career I chose so fast. Sitting down and hearing the stories of my professor when he first started, I was like, I want this so badly.
Yeah, like
I never pay attention in class.
Right, in high school you don't. Right, yeah. When you get to well, in high school they force you, right? They force you to take these classes. They force you to do homework. They force you to show up. Blah blah blah. You're like, I don't want to fucking be here. But then you get to college and no one's forcing you anymore. Like you don't have to show up to class. I don't give a shit. Like you're giving them money, and yeah, you really have to be there because you want to be there because you want to do stuff. You're excited. That's super cool, man. Fuck yeah.
I love my campus too. It's going there for the first time. It was
Remind us where you are. You're in Canada somewhere, right? Canada?
Yeah, Canada, Ontario, Windsor, Ontario. Currently at St. Clair College.
Nice, dude. St. Clair College. Well, let's look it up. St. Clair College, Windsor. That's a cool word.
Yeah. It's the Queen's last name. That's what it was named after.
Oh, nice. Oh, there's a lot of grass, dude. Fuck yeah, dude. Oh, the sky looks nice.
Beautiful. Yeah.
Awesome,
that's the
dude.
Residency.
Are you living in the dorms? So you live in the residencies here and stuff?
I'm gonna be moving in next year. It's just because I live like really close to it. But,
oh yeah, so you can just commute for now. Yeah.
Yeah.
Yeah. Super
But
easy.
honestly, they offered because right now they're even live. It's St. Clair Gaming. They offer free tuition and free residency if you can get onto one of their team. It's their varsity.
Oh, they
team.
have an esports team?
Yeah, they're very popular for it.
Oh, sick! Competitive video gaming. Wow. What games do they play? What games do they play?
They have League, Rocket League, Call of Duty, Valorant.
This is the big coffee place, like Tim Hortons, right? Tim Hortons is like a big coffee.
Oh yeah, we have like 2 Tim Hortons inside the college, and they're always like so fucking long.
Dude, look at this roster.
Boys in there and everything. It's
yeah, dude. I used to love, dude, the college mess halls. The college mess halls are fucking great.
Yeah.
Yeah. Damn. Okay, I see all these games. Head coach, assistant coach, role, flex, main AR. Dude, what is main AR? Like he's an assault guy? Like what? Role SMG? Dude, what? Oh, this is Call of Duty.
Yeah.
Oh, no way. They put them down by like what? Oh, there are no snipers, dude? What?
Yeah.
No snipers? No sniper mains?
Nah, they don't use that. It's so weird to me. I think that's what the flex goes down to. I'm pretty sure, if I'm not wrong.
Oh, I see.
Just
Okay.
League of Legends.
League of Legends. I love this that they have their role. Top, jungle, support. Cool. ADC. Overwatch. Yeah. Flex. Main tank. Nice. This dude's a tank. His name is Squeak. Squeak the tank. Rocket League. Oh, that's cool. Valorant. Wow, they have almost all the games, dude. Yeah, the Val
That's
team.
what I'm trying to join right now. Yeah. The minimum is the highest rank, currently Radiant. I'm so close.
Oh, so you have to
It's so
qualify
far.
that in like outside of the team before they let you on to the esports team.
It's that, or you have to be high mortal, and I'd have to go in and have someone watch me. But knowing me, I'd fumble. So I have to
Oh, I
get
see.
used to having people watch
Rainbow
me.
Six. Wow, dude, this college has the most diverse esports team I've ever seen. That's really cool, man.
Oh yeah, they dominate across all of Canada. It's actually amazing.
I wonder if Sam knows about them. Sam used to play competitive. I think he used to play competitive Overwatch or something. Let us know, Sam, if you know about this team. I'm curious. I mean, you know about like 100 Thieves and all those people, yeah?
Yeah, 100 Thieves, Leviathan.
Well,
Not keep up with most esports teams just because they're with Valorant.
that's super cool. So if you make the team, you get to like live in the esports dorm.
Yeah, everything is for free. They have a huge gaming center right beside the mess hall,
Uh-huh.
and since I paid full tuition, it's free for me. I just go in there
Wow.
with my student ID card. They have 10 gaming PCs, about 10 grand, 2 PS5 with huge screens, 2 Nintendo Switches. and
Oh, you just have
2
access to just like a gaming center, dude? What?
Yeah,
That's
pure
fucking
access.
sick.
It is amazing. That literally the reason I fell in love with it.
See, isn't college great, dude? This shit doesn't
I
exist
love
in high school.
college. Yo, stay
I
in
love college.
Please stay in school. You'll love it.
Yeah, dude. Yeah, go to college, kids. That's what I say, dude. Like, what? You have a gaming center. You can just go over and play video games, like LAN party shit. That's fucking dope.
Bro, it gets so full so quickly though. Like
Oh, I bet.
you'll see people like yelling into the. I love when people start yelling into the mics and raging.
Damn, this is cool. Fuck. Is this the thing, or this is something else? It's probably their stadium or something. I'm guessing. One second, let me show on the screen.
Yeah, that's the one. That's the one.
So wait. Oh wow. So this is where you can just go up and just play.
Yeah, I literally went up there and just started playing.
Oh, that's dope. This is like a full esports like stage. Is what this is.
Exactly. It is beautiful. I love
Oh,
it,
man.
especially at nighttime.
What's the Sam would know this. He's been to, so we have it down the street from us. We have, I think, the Epic like headquarters or something where they host the championships.
Oh.
Yeah, do you know what it's called? Yeah, what is it?
No, I never like followed the
Los
Fortnite and
Angeles. Maybe it's not Epic. I think it's Riot. It's called like
Games. Oh yeah. It's
called RCS?
Riot headquarters. I think it's
Yeah,
Riot headquarters.
HQ. I think it's this.
Yeah, I've
Yes.
always wanted to go to this one.
Yeah, this is down the street,
beautiful.
from me and Sam. This literally, it's right down the street.
You are the luckiest human being ever.
Yeah,
I
this
promise you that.
this is where the League of Legends tournaments are held, right? Riot, League of Legends. Yeah, Sam will sometimes he'll just go get tickets. You can get tickets or something. You can go watch. Oh, this is an LCS. LCS. It's called the LCS. Yeah, the LCS championship venue. Wait, let me see. LCS venue. Where's Sam? Sam was in our chat earlier. LCS venue. No, not Rochester, dude. What? Los Angeles. Video games. I want like a picture of like what it is from inside out. It looks really cool. Yeah, it's like this. It's like a big game show.
Yeah,
Almost.
it is. Yeah, no, that is lovely.
Wow.
Oh, I remember this. 100 Thieves. This was Lev. I was watching this show. Holy fuck, you are so lucky to be so near
Yeah.
this.
Should I go to
Oh,
this?
that's loud.
I could literally walk down the street to this. It's right right next door to me.
I would so recommend it. Even if you don't play the games, like just the whole vibe of the crowd.
Just get the
you'll
atmosphere?
love it.
Yeah,
Yeah, the atmosphere plus is like unreal.
I'll have to check it out. Yeah, because I mean, a lot of how this server started was like playing video games, and I haven't played as much lately. But I need to start getting back into it. I need to like start remembering what the core like attraction
Yeah.
thing was, which was video games, and I do enjoy playing them, but it's just making time for it and stuff. But yeah, esports is really cool. I might meet up with some esports people. Next month is what's called LA Tech Week, which is a week where a bunch of companies just host these like free parties all over LA, and they're meant to be like networking opportunities, like mixers and stuff.
Oh my god!
Yeah.
Dr. Gold, I might be coming to you because
Oh,
I
when?
just signed up for one of the LA ones. Holy
Oh, dope.
shit! Yeah, I'm going to Michigan tomorrow, and then Ohio, another someplace in
Wait,
fucking
you're flying?
Illinois.
You're flying all over the U.S. for what?
For networking for biomedical engineering. Since it's like a really small like industry in itself,
Okay.
I think it's best to just start off early, get my name out there,
Okay.
just so when I finally graduate, it's just like I'm not gonna have to sit there looking for jobs. Because
I
the
think-
city I'm in, there's only one opening ever.
Yeah, no.
And that's
And
200 people.
you will go somewhere else. You will definitely go somewhere else after college. And I say you honestly should. Like, you should never like stay in your hometown for too long. It's good to go see like new places. But that's a good idea. Yeah, to network, just at least get your name out there. Getting internships would be very useful. I don't know how easy that is as a Canadian citizen trying to get internships in the U.S. Sometimes it's
I
tricky.
have dual citizenship. That's the best part of it.
Oh, your
So
money,
it is
dude.
great.
Your
Yeah,
money.
I am set for
Your-
life. I have the dual
Yeah.
citizenship.
Oh, you're fucking shot, dude. Oh, okay. So wait, when are you coming to LA?
I think it's sometime in June.
Okay, nice, dope. I'll see you next year then.
Let's see.
Okay, so yeah, you were also looking for like a friend in biomedical engineering. Do you know who Zev is? Hebrew Hammer. He's here. I'll link you his. How do I link profiles these days? Copy user ID. Oh, here you're in the chat
Yeah.
at least, right? Okay, so
Yeah.
here we go. At Demented. Here is Hammer, who is my friend that has a biomedical engineering degree. So yeah, so Zev went to school for biomedical engineering. He didn't end up doing biomedical engineering afterwards, but he did the whole degree program. He has a degree in it from University of Texas. So if
that's
you have,
perfect.
and he knows people that did go into jobs and stuff. So if you have any questions
Yeah,
about
that's what I
like
need.
if you know any,
Exactly, that's
if you have any
exactly what I
questions about like how the college thing works, like what classes to take, like what the opportunities are, he can help you out. Feel free to send him a DM, and then also I'm sure he can put you in touch with some friends that that did end up. He went into funny enough, he went into microchips, and then he went into video game testing. So he kind of did a little bit of a switch, but he did do biomedical engineering. He has a degree in it. He has a bachelor's of science in it. Yeah. Yeah. Nice. You need help with any of your homework questions, Sensation? Or not Sensation, sorry, Demented?
Oh yeah, I posted it in office hours. It's
yeah.
for it has to do with bits and shit. I physically couldn't understand the fuck.
Okay, let me
I
find
don't
it.
even get it at all.
Nice. It
It's
looks like
bits in the ACIS, I think it's called, or
Okay. Let me pull it up.
ASII. Yeah.
Oh, wow. Bits. Okay, cool. All right. Let's do this. We'll start off the stream, and I'll help everyone with their questions. Because, yeah, I see Patty's got questions, and then I think someone else does. But, yeah, we'll do them out. All right. Let's start off the stream. All right. Welcome, everyone. Office Hours. My name is Dr. Goldsack Education, a stream that helps you with math homework, science homework, all sorts of fun stuff. Why is my webcam not working? One sec. No? Where's my webcam? Excuse me? One sec, let me find it. Okay. Where is it? No, webcam. Yes. Okay, there's webcam. And then... Oh, this is the other webcam. No, I don't need this one. One sec. It's... Which one is it? It's this one. Okay, cool. There, one sec. Don't want to work today? Ah! I swear. Technology, you... pain in the ass sometimes. Which one is it? It's gotta be... Oh, man. Which one is the webcam? I think it's this one. It's gotta be this one. Okay. There we go. There we go. Okay, cool. Now I'm here. Although my screen is all fucked up. Let's see. Elgato. camera hub. Camera sharpness, exposure, not automatic. Well, yeah, automatic. Where's brightness? What the fuck is brightness? Brightness. There we go. Okay. And then let me turn the white balance off. Okay, cool. Got it. All right, let's see. Okay, so I see a big lab thing here. Numbers. Okay, so you're going through binary, I guess is what it is? Yeah?
Yeah.
Okay, so this is decimal. Decimal means like base 10. And then binary is a way to take all those numbers and put them up in terms of like powers of 2 is what it is. Why is this not working either? There we go. Okay, cool. All right. Yes. Oh, and then hexadecimal is base 16, which is even weirder. Do you understand how the bases work? Do you want me to go through that?
Can you go through that?
Good. Got you. All right. Yeah. All right. Here we go. All right. So, usually, right, in base 10, okay, which is called just regular decimal, okay? You have you have places, right? This is what's called the ones place. This is the tens place, right? Or actually, sorry, it's backwards. It's this way. Let's say this is like the hundreds place. This is the tens place, and then this is the ones place, okay? And then your options, right, are 0 through 9. You get 10 options, okay? So, for instance, if I wanted to express the number like 3, it would be 0 100s, 0 10s, and 3 1s. Do you see how that gets you 3?
Okay, yeah.
Okay. If I wanted to express the number, I don't know, 69,
Nice.
that would be 0 100s, 6 10s, and 9 1s. And so that's how you would get 69. Okay?
Okay.
Okay. Now I want you to notice like the places of this, okay? Do you see how the ones place? This is 10 to the 0. This is 10 to the 1. This is 10 to the 2.
Yeah.
Okay? This is what base 10 is. All right? We can get even more complicated because now we can do what's called binary, which... Does binary read left to right? One sec. Let me see. Sorry. They do read it left to right.
Right to left. Do they?
Well, here sensation looks like they're reading it left to right, right?
No.
That's fucking weird.
No, it's right to left.
It's
No,
right to
I was
left.
told, yeah, right to left. I was told it had to be right to left.
Well, I mean, look.
When I
Well,
tried-
okay.
yeah.
Well, look at this. Well, look at my example here
Yeah.
for number 6, right? 6 is 0, 0 1s, 1 2, and 1 4. That's 4, and then 0 0. They're reading it from left to right.
Well, that's so weird. He told me to write it from right to left. I was like so confused.
Yeah. Well, I mean, that's what I see here.
Yeah.
It's not.
I feel
'cause
like-
it's counting from the right.
Oh, it's counting from the right.
The
Oh,
binary is counting from the right.
Oh, sorry. That's what you mean. Sorry. I mean, you write out. Yeah. Yeah. You're right. You're right. Sensation. Yeah. Sorry. You are reading it from right to left, but the biggest numbers are at the left, I guess. is what I'm saying.
Yeah.
Got it. Okay.
Yeah.
All right. You guys are right. I need to eat more salami. Okay. So this is base 10. We could also have base 2. All right. So that would be 2 to the 0, 2 to the 1, 2 to the second, 2 to the third, which corresponds to how many 1s, how many 2s, how many 4s, and how many 8s. Okay? So if I wanted to express the number, let's say 7, how would I do that?
Number 7 would be. Hold on. 7 would be 0 hundreds, 0
no.
tens.
Yeah, so here
Oh.
it would just be 007. I'm saying in
Yeah.
binary, so base 2, how would I express 7? So 8 is too big, right? So there's 0 8s, right?
Mhm.
But there's at least a 4, right? And also
Yeah.
notice that this can only either be 0 or 1. You only get 2 choices. It's either yes or no. It's either like there's ones.
Yeah, I got it. Yeah. Ones
Right,
and
good.
zeros.
Okay. Base 10 here, this has 10 options. You have 10 options for how many ones you can have. 0 to 9. Okay. So, yeah, you have at least 1 4, right? Do you have any 2s?
At least one. Yeah, you have at least
Good.
one.
At least 1 2. So 4 plus 2 gets you
and then another
6,
one.
right?
Plus 1 again.
Plus 1 again. Right, good. So do you see how that gets you 7? So that's how I write 7 in decimal into binary, okay? Now, we can also do base 16, which is called hexadecimal. Okay? Hexadecimal works like this. Again, you have the 16 to the 0. They call this the register, by the way, sorry. So the 16 to the 0 register, the 16 to the 1 register, and the 16 to the 2 register. And this can go from 0 to... Is it F, Sensation?
F.
What is heck? It is F. Okay, good, yes. 0 to F. Which is weird, right? It's like what? What do you mean 0? Why are we messing up letters and numbers, right? Yeah.
Algebra all over again. Love it.
Yeah. Well, it's because we want to express everything in the register as a single character. So I can go 0 to 9, right? That'll get me 10 of them. And then I need A, B, C, D, E, F. That gets me the other 6. So that there are 16 possibilities. So once you get past 9, instead of writing 10, because 10 is 2 characters, we just write A. And then B, C, D, E, F.
Okay, that makes sense.
Does that make sense? Okay.
Yeah.
So if I wanted to write down, let's say, what do I want to do? Sorry. Let me think of... Okay. Let's say I want to write 36 in hexadecimal. Okay? How would we do that? So 16 squared, right? That's 256. This is the 16's place, and then this is the 1's place, right?
Yeah.
Okay.
So 16 to the power of 2, too big.
That's too big.
Yeah. It has at least 116. So this
it has more than 116. It has 2 16s in it at least, right? Because 16, 32. What's up, Enigma? We're going through the conversions between decimal and hex. Yeah. So here, look at what the issue would be. If you wrote just 1 here, right, 16, then I need to somehow get 20 from this, but I can't. Yeah,
so
exactly. I can't do that.
Yeah. So it'd be 2, not 2.
It would be 2.
No, 2. Yeah, it would be 2, 4. 2, 4.
Good. 2 to 4. Yeah, very nice. Exactly. Yeah, and so how they write this, when they write this in hex, is they write this as, I think it's 0x, they do this.
Yeah, 0x.
And then I guess it's 1, 2, 3, 4, 2, 4. I guess it depends on this, how many characters there are. I think they do this usually.
Actually, let me see if I can pull up the one that he uses.
I was going to say I wouldn't.
Yeah.
Yeah, because
I would have 1 leading 0 and then
1 leading 0 and then that. Okay. Enigma says he did this in class like 2 days ago. Oh, that's cool, Enigma. What class are you taking? Yeah, this is another one of our students, Enigma. His name's Demented. He just started college, and so this is his lab class for, looks like digits. Digital circuits. Well, looks like he's taking digital labs, so it's kind of the same thing.
Yeah, it's the same thing, just renamed.
Do you all go to the same college?
Maybe.
Yeah. Yeah. The reason why that we use hex a lot is we use it for colors. Okay. So.
Oh yeah, the hex code for a color. Okay,
yeah, hex code for colors.
Like F something, F000, which should be black, if I'm not wrong.
Right. So yeah, black would be 0000, and how many? That's 6 registers then. Okay, so that's 6. Yeah. And I believe that's because it's is it? Do they call it 16-bit? What's the color? What's the name for it? They call that something. It's like 16-bit color or something. 256. Oh, it's 256-bit color. I think it's 256-bit color.
Not necessarily.
Well, okay, yeah, no. Yeah, well, okay, because it's RGB, and it's 255, 255, 255. So you have, okay, now I remember how this works. I remember how this works for color. It's actually a little bit different for color. Okay, so what they do is they do this. They do 0x, and then it's like placeholder, this is red. Placeholder, this is green. Placeholder, this is blue. Yeah. So it's actually not a decimal number. It's a triplet of decimal numbers. Because if you have 2 registers, right? If you have this and this, you can go all the way up to 255. So watch. Yeah, from 2 registers, right? So this is the 1's place, and this is the 16 place. Do we see that demented? Okay. So, again, remember the most amount of 16s I can have is 15 of them, which would be F. Okay? And then the most amount of things here I can have is also 15, which is F. So we have 15 times 16, which is 240. Okay, so this gets me 240. And then 15 here gets me a grand total of 255. And so, yeah, this is an important thing in colors, is that you can express all the colors in combinations of RGB from 0 to 255. That's where this comes from. Yeah, Sensation has a computer science book. What's this? AQA? CSE? What's this? Oh, GCSE is for CS. Oh, that's cool. Yeah.
Go ahead.
Oh, okay. Okay, so you have there. Okay, cool. Yeah.
Anyway,
so,
255 times 255 times 255 is 16 million colors. 16
million colors. That's what I'm thinking of. Sorry, I remember it was a certain number of million colors. Because that's what they would advertise for screens back in my day. They'd be like, it's a 16 million color screen.
Nice.
Go buy it. Nowadays, everything is like a gazillion colors or whatever. Okay. So this makes sense, at least, how like decimal, binary, and hex are related with all this stuff here. Yeah? Okay, cool. All right, so let's see what your lab is and like where we're getting a little hung up. Okay. So converting numbers.
And I've got that in front of me.
Nice. Here, let's maybe try. Let's have Demented try to do some of these, just on his own. Let's see. Okay, they want you to convert this from binary to decimal. How would I do that?
You would have like the 1 plus 2.
Good.
2x, I think.
High Potential wants to collaborate, dude. What does he want to do? What does collaborating mean? Okay, whatever. I'll accept if he wants to come in. I've never done one of these Twitch collaboration things, High Potential, but you're free to come in, dude. Someone, I don't know how this works, but whatever. Okay, yeah. So this would be right. This would be a 1's place, right?
Yeah.
This would be the 2's place. Okay. This would be the 4's. There's none of those. There's none, and this is 8. There's none of these. So then, what's this place?
16th.
16. Good. Okay. So if I add all these numbers up, right, what do we get?
19.
19. Nice. Good. Does that make sense?
Yeah.
Okay, cool. So we know that. I assume you can do the other ones as well.
Oh my god, that's what's it called? I did it that way, but then the professor told me I was wrong. That's why I was so confused. That's what I done, because it comes with the lab in the front of the table. Which I was going through it. Then he said it was wrong, and he had me do like one.
We said this was wrong. We said 19 was wrong.
Yeah, because I did the whole thing.
He's wrong. He's wrong.
And then because he posted. I sent the PowerPoint as well. He posted this thing, and I was like very confused on how he did it. It's supposed to be like 5,000 whatever. It's like 500. Da, 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 da. It's just a very confusing thing.
Yeah, he's probably doing modulus or whatnot. Does he use Yes, equity. We can do your question next. It's like this. Well, well, let me see what Patty needs. But okay, cool.
Be here.
Patty says, "I'll be here. I'll be here." Yeah.
I was just muted the whole time. I came back a while ago. I just.
Oh, you're good.
Talk.
You're good. You're good.
Yeah.
What do you?
I'm just kind of reviewing some stuff because the reason I came into the call today was because I have my first chemistry exam tomorrow.
Ooh.
So.
Okay. Cool. I'll help you. Yeah. I'll help your question next, and then equity. I'll do yours. Cool.
Yeah.
Good. All right.
Yeah.
Okay, so from decimal to
I already
binary.
have the problem finished. I just have a question about like why you do it the way you do.
Sure. Yeah, just like a method thing. Yeah. Let me know if you have to bail to go to like hockey practice or something, and then I can answer it real quick.
Wrong kid. That's Philip, not me.
That's Philip. Okay. I thought you both play hockey.
We both do not play hockey. We play soccer.
Okay.
But I don't even play soccer here. So.
Yeah, I just played IM sports when I got to college. I was just like, you know.
Yeah.
Not gonna hit
the way to go.
Yeah.
Okay.
Oh, here, I sent it in screenshots. That's the way he wanted me to do it.
Oh, okay. I mean, this is kind of the same shit, dude. It's kind of the same shit of what we did. What's this?
I didn't do like, see, he's like, you have to do it this way.
Well, I mean, that's what we did. Look, this is the ones place, right? The ones place. This is the twos place. This is, and then he's just adding it up, right? So it's 1 times 2 to the 0, right? So 1 times 1. Then it's then it's 2 times 2. See how this is 2,
Yeah.
sorry, this is 1, 2, 4, 8, 16, 32, 64, right?
Okay, so yeah, what he wanted me to do was show my work. That's what confused me so much. It's like, how the hell
okay.
did you get there? Yeah.
Yeah, no. He's just showing what the registers are. That's all he's doing.
Yeah, because at the start it was, I just like looked at the binary table and then I just followed the zeros and I seen like, oh, 19, so I just put in 19.
Yeah, that's all you really have to do.
No, this is longhand.
This is longhand, yes. Yeah, Sensation's right. This is the long way to do it.
It's what we'd probably be doing in year 9, so I'm not really quite sure why they're doing it in college, but
Yeah, I feel like you can just say what it is. I don't know. Some teachers are fucking anal about stuff. They're just like, meh. Okay. Let's see maybe this one. Let's do the hex one. We need to make sure you know how to like convert, sorry, from decimal to binary. Do you know how to convert from decimal to binary?
Oh yeah, that one is just like divide by 2, and then if it's a decimal number, then you have a remainder of 1. If it's an even number, then it's a remainder of 0, and then you just write it out from right to left.
Okay, so how would you write this one from right to left? How would you do it?
So that one would be 87 divided by 2, and then I think it would be 44.5.
That's like 43.5.
No, yeah, 43.5, and then since it's a decimal, you'd have a remainder of 1. So you put that down, and then you divide the 43 again.
This is such an interesting method. I have no clue how this method works. I just want to see if you get the right answer.
Holy hell, I'd have to start writing this down, but it's basically.
Well, I want to see if you get the right. Show me that you get the right answer. Yeah, tell me. Right?
Okay,
do you have a pen and paper with you? Make sure you get the right answer. Yeah. Because I have no clue what the fuck this divide by 2 and remainder method is. It's probably something to do with modulus. But
I'm doing it right now. 40.
I want to see, dude. I want to see what this method is. Then I'll show you how I would have done it.
I would most likely rather your method at that point.
Yeah, dude, this guy sucks.
I mean, to be fair, he's like 87. I can't hate on him too much.
Oh, I see. Okay, he's a little geriatric. All right, that's okay, man.
It's fine. It's life. You got to deal with those silly teachers.
It's life. Yeah, you do.
Where's my calculator?
Yeah, I don't know about like dividing by 2. That's such a weird thing. Like, keep dividing by 2.
You just keep dividing by 2 until you get to 0.
And then what? And then what?
And then with the remainders, since you have
and then you see. Okay, wait. I think I'm seeing it. And then you see how many times you had to divide by 2.
Yeah, exactly. Kind of like that. So here, I'll do it right now, very, very quickly.
Okay.
So then the next one would be 21.5 for the 43. So it'd be 21 divided by 2, and the remainder for that one was 1, and then 21 divided by 2 again. You get 10.5. So then you put 10 in the next one, divided by 2. And that would be 5, so the remainder would be 0. And then it's 5 divided by 2, 2.5. 2.5 would have a remainder of 1. Then 2 divided by 2 is 0, so you'd have 0. So it'd be 0, 1, 0, 1, 1, 1.
All right, let's see what you got. So you said 0, 1, 0, 1, 1, 1?
Yeah.
Okay. I think that might be correct. Let's see. So 1, 1, 1, 0, 1, 0?
Yes. No, you wrote it backwards.
Okay. So sorry,
Yeah,
it's what is it?
So it'd be 1, 1, 1.
Yeah.
And then 0, 1, 0.
Okay, let's see if this is correct. 32 plus 16 is 48, plus 8 is 56, plus 2 is 58. So not quite. I think so this doesn't work, right? You want to see my method?
Yes, please, because that's what he told me to do. So
Okay, so I just write out the registers the same way he kind of did this. Oh, I got a drink. Oh, thanks, Sam. Sam always making me chug. Okay, so the same way that we wrote at the register, right? 2 to the 0, 2 to the 1, 2 to the second, 2 to the third, 2 to the fourth, blah 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 blah, right? Okay.
Yep.
That's what these represent. Okay. I'm gonna look at my number and see where is the highest number in the register that doesn't go over it. 128, too big, right? 64 is great. Okay, cool. So just 1, right? All right.
Yeah.
So now I have 87 minus 64, right? Which gives me 23, all right? This is my new number that I have to see if something's bigger than, okay? 32, too big, right? So we're not going to put that one in. 16 is good though, right? We like 16. 16's under 23. So that's cool. So then I do minus 16. Now I'm down to 7. 8, too big. 4 looks great. That's going to be 1. So minus 4, now that gets me to 3. 2 is great. Cool. Minus 2 gets me to 1. 1 is great. And now if you add them up, right? So 64 plus 16 is 80. Or sorry, is 80. 80 plus 4 is 84. Plus 2, 86. Plus 1, 87.
Yeah. So I can see my mistake because if you look at the top, I think I missed the 1. The 0, 1, 0, 1, 1, 1. I think I missed
the 1. You forgot this one.
Yeah, I forgot that one.
Okay.
So what is the right method? Yeah,
okay, it's the right method.
Fault, not the yeah.
Okay. Yeah, that works. I mean, it's more important. I really want you to understand, again,
like how it works, not
why it works, rather than, if you're just memorizing some fucking process or something, man, it's like, it's not going to help you out when it changes to, like, I don't know, like hexadecimal or something. Because then you're like, oh shit, what's the new way to divide things? You want to know conceptually why this is.
Yeah. But he forces it down to, like, follow this process. Nothing else works, just that process works. No. Yeah.
Okay. That's whatever. Okay. All right. Yeah, that's yeah. Whatever you want. That's bull. Like for me, as a teacher, I don't care how you do it as long as you get the right answer. Like I feel like there's a lot of different ways to do it. So you know, as long as it's not some bullshit way that you're getting it, then okay, it's fine. Whatever. Okay. So then decimal to hex. We went over that. We did an example of that.
Yeah.
What is this? Convert the following numbers from signed decimal to 8-bit 2's complement. The hell is that?
I skipped that part. I literally just told the teacher like I wasn't here for the first class. And he's like, yeah, just send it in. I'm like, okay.
But I don't know what BCD stands for. Figure 2.2? Oh, it says there's like a figure or something. Oh, we need some figures. Where are the figures?
Oh no, it's the numbers they showed are from straight from the figures, just in case you don't have the textbook.
Oh, okay. Okay, weighted binary codes are used to make conversion to decimals easier for people. Only the numbers 0 from 9 are stored in binary. ASCII is a 7-bit code used on... okay. Since 2's complement numbers? Dude, what are these, dude? I haven't heard of these before. Like, this is...
That's the thing. It had me so confused.
Yeah, okay. You know what? I'm just gonna go ask ChatGPT.
Oh yeah, BCD says binary coded decimal.
What's up, Zach? Zach, I feel like Zach knows what's going on. Solve this. I'm just gonna tell ChatGPT to solve it for me. Oh, the 2's complement. Cool. Okay. If the number has fewer than 8 bits, pad with leading zeros. For negative numbers, first convert to absolute number to binary, pad to 8 bits if possible. Find one's complement by inverting the digits. Add 1 to the 1's complement to get the 2's complement. Add 1. Okay, so yeah, 8-bit just means there's 8 numbers. Okay, so here let's just see the process of what's going here. Super weird. I've never heard of this. Zach, why have you heard of this?
If he knows, maybe he should start teaching with you.
Yeah.
That'd be great.
He has his own stream actually. So here, I'll shout him out, dude. Zach's a great guy, dude. He's another mass streamer friend of ours. He has his own streams. Oh, he says I was a former CS major. Ooh, okay. Yeah, that's dope, dude. Okay, cool. Yeah. Shout out to Zach. Yeah. Yeah, Zach's working on a dissertation for his math degree, so he's a super smart guy in math. But okay, let me see what this is. And then let me pull. What was it? What was this one? Oh, we're learning some stuff today. That's great. Love learning. Okay. So, okay, the first thing is to convert it into binary. So that's the first step. Convert it to binary. Which, yeah, with 35, right?
Yeah.
This is like the ones place, twos place, 4, 8, 16, 32, right? So 35 is going to have at least a 1 for the 32. Then 0 16s, 0 8s, 0 4s, and then a 2 and a 1. That gets me. And then here's the thing. They say pad it. So padding means you need to put whatever thing's on the left so that it has 8 digits. Okay? Right now, this only has 6 digits. So we're going to pad it with this. We're going to put 2 zeros there. Do you see that?
Oh, so you just add in extra numbers?
You add 2 extra numbers on the left, or however many numbers you need to make it 8. Okay? 8 digits.
So it would just be like extra zeros. You can't add a 1. It has to be all zeros.
Yeah, you can't add numbers. You add zeros on the left. Okay? Then what they say is invert the bits. Invert the bits means switch all the numbers. So if it's a 0, it's a 1. If it's a 1, it's a 0. Okay? So we switch all these. So then that becomes 1 1 0 1 1 1 0 0. Right?
Okay.
I just switched all these numbers. Okay. And then they say, so that's the ones complement, apparently. I don't know what that means. But then the twos complement means you add 1 at the end. So this becomes a 1. Okay. Let's see how it would work for 20. So 20, right, would be at least a 16, no 8s, and then a 4, and then a 0 and a 0. It's 0, 2, 0, 1s, okay? This is only 5 numbers, so you need to pad it with 3 on the left, okay? Then you need to invert it. So that's 1, 1, 1, 0, 1, 0, 1, 1. And then they say add 1. So I wonder if this goes to 0, this goes to 0, and this goes to 1. I need to check that.
I think that's for the negatives with ChatGPT.
Oh, okay. Wait. No need for padding? Why is there no need for padding? Oh, because they already did it. Oh, okay. Oh, because it's positive, you don't have to add 1. Okay. Oh, but look at this one. So for negative 100, okay, look. So they convert it to binary, right? They flip the digits, and then they add 1. Okay, but that's adding 1 in decimal, okay? Which means to add 1, if you can't put this up anymore, right? Because it's already at its max.
Yeah.
So it has to go to 0. The next thing has to go to 0, and then this thing has to go to 1. That might be a little strange. That's strange. That's strange. Here, let me show you how it works. It has to do with this. Okay, let's just say we had 0 1 1. Let's just say we had 0 1 1. What would that be in decimal?
In decimal, that would be is this for hex or just normal?
No, normal binary to decimal, right? This would be 3, right? Because this is the 4's place, the 2 place, the 1 place.
Yeah, it's 2 place. Yeah.
Okay, cool. So if I want to bump this up to 4, right? How would I write 4?
You'd it'd be 0 1 1 1.
No, it'd be 1 0 0. Because this is the 4's place. This is the 2's place. This is the 1's place.
Okay. I see now.
It's kind of like it's kind of like rounding. So for instance, if you had like 5.956 and I tell you to round this, right? You know, if you round this one up, right? If I round to this place, this has to become a 6, right? But let's say I want you to round to this place, right? Rounding to this place, this has to go up 1, but it can't go up to 10, right? So it restarts to 0, and then the next register goes up by 1.
Okay.
Do you see that? Yeah. Like, if I round 5.99 to this place, it becomes 6.00.
Yeah.
It's the same thing here. I'm trying to add 1 to this. I can't because that would jump it up to 2. That doesn't exist. So I need to make it 0 and move the other register up by 1. But if I move the other register up by 1, it also goes to 2. So I can't do that. So I'm also going to mark it down, and then I'm going to move this one finally up to 1.
Oh, okay. Yeah, I get it now.
Do you see that?
Yeah.
Yeah. If you had, for instance, 2, right, which would be 0, 1, 0, and you wanted to add 1, that's cool. You can just add 1. That's great, right? This one's okay to add. If you had, for instance, 1, 0, 1, which would be 5, right? And I wanted to make this up. I wanted to go up to 6. This can't go up, so it goes to 0, and then this one goes up, and that becomes 1, 1, 0, which, right, 4, 2, 4, 2, 1, which is 6.
Yeah.
Starting to see that? Yeah?
Okay, yeah, this makes more sense.
Okay, good. I'm glad this makes more sense. Yeah. Okay. Oh, man. So yeah, that's how you do that. Again, negative numbers is the only thing where you have to move it. Convert the 2's complement to a signed decimal. So this is where it's weird because how do you know it's negative or not? Like, how do you know it had 1 added to it? Right? How do you know it was inverted? Like, how do you know? Oh, he says the first bit.
Yeah.
Okay. But what if this was like 1, 1, 1, 1, and then I added 1 to it, so they all went to 0?
No, the first bit.
Oh, sorry, the first bit. Okay.
The leading one. If it's a 0, it's a positive number. If it's a 1, it's a negative number.
No fucking way, really? Oh, because 2's complement. Dude, I love Zach here. Zach's got all the math, dude. Thank you, Zach. Okay, I gotta see this. Wait, why can't I go to your link you sent me? Oh, moderate? No, I don't want to moderate, Zach. I just want the website. Oh, okay. 'Cause apostrophes. Yeah, the apostrophes fuck things up. All right, let's see. Oh, okay.
This is what I'm gonna have to do? Oh my god.
Yeah. Okay, so that's it. I agree this would be unsigned would be a 4, but then because it's a 1, that makes it negative 4? Oh, okay. Okay. It would take me a little bit more time to figure out the theory of why that is. It's something to do with flipping the bits and adding 1, but for now... Oh, the 1 tells you to find the complement? Okay. Then yeah. So for now, it's we're just gonna say that if we see a 1, then it means it's negative. Okay.
Okay. So if it's the first number and it's a 1, it's a negative. If it's a 0, then it's a positive.
Yeah. So for instance, this one, right? This one is for sure negative. Okay.
Yeah.
So let me show. This one right here is negative. So let's work backwards, right? So I'm gonna subtract 1, right? So that means it's gonna be 1, 1, 1, 1, 0, 0, 0, 0, and I know it's negative. And then I'm gonna invert. So then that's 0, 0, 0, 0, 1, 1, 1, 1. Oh, Zach says wait. Oh, am I not right? Did I do something wrong? Oh, you think you did that one wrong? Oh, okay, okay. So this is 1 plus 2 plus 4 plus 8. So then that's 12, 14. This is 15. Negative 15.
Okay. Negative 15 because there's a 1 at the front. Okay.
I
this
believe
makes
so.
sense.
Here,
Yeah,
and
yeah, yeah.
we can put this in ChatGPT. I can say, like, solve the second one. I'm just curious. I'm just, let's see. Okay, cool. Invert the bits. Yeah, negative 15. Cool.
Yeah, negative 15. Yay.
Nice. Zach says, "You do your thing." I don't know if I'm doing my thing. I think I'm just like flailing around. Honestly, that's what's happening. And then BCD and ASCII. Man, that's a lot here. Here, let me help. Patty with this thing real quick, and then if I have more time, just stick around, and I'll do the rest of this assignment for you with the time I got. Is that cool? Okay, cool. But this make more sense so far?
Yeah. Thank you so much.
You're very welcome. Yeah, I love this. Like, keep sending this shit to me because I love learning, honestly, too. I think this is really cool. I appreciate this. Yeah. Okay. Patty, what's up? What do you need help with?
Okay. So, hold on. What did I submit again?
It says, "What did I submit again?" Yeah, let me get it real quick.
So, yeah. So we've been going over, like, I'm in General Chemistry 1, so we've like, so far we've been just going over like photons and light and wavelength,
and
frequency,
photoelectric effect or something, right? Maybe,
yep,
or
all that jazz, and then like
cool.
Bohr's model for hydrogen as well. That's what we've been kind of working on.
Yep. Okay.
And like, obviously there's a lot of units involved, a lot of conversions and all that stuff. So, like, I think specifically with the problem, it was just kind of confusing because I had to figure out what s to the negative first meant, but then I remembered that hertz is 1 over time, or s,
so it's
I
1 over
kinda
seconds.
figured that out.
Yeah. 1 over seconds. Yeah.
Like, yeah, I especially have problems with just finding the number of photons, like, in that given like problem, like the one that I just submitted.
Yeah, I'm loading it in real quick. Here, 1 sec. I don't know why it's taking so long. You probably gave me a super high resolution image. Is what you did.
I have no idea. It came from my iPhone camera, so.
Yeah, because like I can zoom in on like the pixels. I can see the pixels.
Oh my god.
I know it's loading it. Okay, here
Yeah,
it
I mean,
is.
it's all worked out there.
Okay.
And also, okay, so the main thing is with the units are kind of messing me up right now is that on the bottom, you know, where it says like number of photons equals and then all that mumbo jumbo. Yeah, it like, this is like this is what I got from like the key. It was the 4.0 times 10 to the negative 21st on top, and then the other thing on the bottom.
Yeah.
But for the answer, it's photons per second, but photons on the bottom and seconds is on the top before I solve it. So I don't know how that.
Oh, so then, well, it's okay. Well, it's joules per photon. So you're dividing by a fraction, which means that's going to throw it right back on the top. Like if you do 1 over x, this just becomes x.
It becomes x.
So remember, well here, let's have an example here. Let's say I have like 1 over a divided by 1 over b. I have 2 fractions, right? I'm dividing them. Dividing fractions easy as pi. Flip the second and multiply. See how this becomes b over a?
Yeah.
Yeah. So if you're dividing by a fraction, whatever's on the bottom of the fraction is going to eventually just go to the top. That's just a math thing.
Go to the top. Okay. Yeah. Just the basic, algebra review there.
Yeah, it's okay, dude. Yeah, no, dude, you're
Except
really good.
With a bunch of decimals and 10 to the whatever.
Well, here, let me walk through this question without seeing the answers, so that I can just like help you with it. Just seeing how I would do it,
Yep.
Because this is a classic question. Okay. So it says radio signals from Voyager spacecraft in the late 1970s were broadcast at a frequency of this. Cool. So I'm always going to write out what that is. That is F, or sometimes what they call is like script V.
Is that like frequency?
It is frequency. That's unfortunate, but yes.
I don't know why they do that. Like, velocity is V and frequency is V.
I know. Cuber, I'll help as many people as I can. I got another hour, Cuber. You're good. Just chill. Just hang out, and I'll help you guys. You're good. All right, so this is 8, right? This many hertz, okay? And then we say that the signals were intercepted on Earth by an antenna capable of detecting 4.0 times 10 to the negative 21 watts.
That's like the threshold frequency. I think,
it's not really a frequency; it's a power. So joules per second. It's a threshold power. Yeah. So what's happening is like, so these are photons, right? Here's like pretty photon, right? And
waves. Yeah.
Photons are getting launched at the speed of light, by the way, right? And what's happening is they're hitting things, and as they hit things, they carry energy, and that is measured in joules, right? Energy is measured in joules. Okay.
What's the conversion from joules to kilojoules? Is it 1,000 joules for
yeah, it's 1,000 joules is a kilo. Yeah. So that's energy. Okay. If you want to measure power, which is watts, right? That's joules per second. Okay. Then that's the number of photons that are hitting this thing per second. Okay. Because, for instance, like one photon, let's say, I don't know, carries like, this is totally unrealistic, but say it carries like 5 joules, all right? So if my antenna is detecting 40 watts, right, 40 joules per second, how many photons are hitting this every second?
8.
8, good. Yeah, do you see how that works? That's why it's photons per second. And then there's an energy associated with each photon. Okay?
Yep.
So, okay, cool. So we have that. We have this. Okay, so at a minimum, approximately how many photons are per second of radiation are they intercepting? Okay, cool. So, yeah, so this is equal. This is energy per unit time, okay? And so what they're going to use is this formula for the energy of a single photon. So energy of a single photon is equal to HV or HF, however they write it, okay? F or V interchangeable is frequency, okay? H is 6.626 times 10 to the minus 34, I believe. And then,
yes, it is.
And then we're multiplying that by...
frequency is the 8.4 times 10.
You're so right. I don't know why I wrote the 4 point. Yeah, you're right. Yeah, it's 8.4 times 10 to the 9th. Okay, cool. All right, where the fuck's my calculator? Calculator. Yes. Load that. Cool. Awesome gravy. Okay, calculator. Okay. All right, so 6.626 e the negative 34, right, times 8.4 e the 9th. So that's going to give me 5.57 times 10 to the 20 minus 24, right?
Yep.
And that is in joules, okay? So that's the energy in a single photon, okay?
Okay.
All right. So I know that this thing is receiving this many joules, right? In a second.
Yeah.
Okay. So then if I want to know how many photons do I need to equal this amount of energy? And then this is, again, energy per second. This will also then be photons per second. So, like, here's, like, the thinking, I think, of it. So, like, in 1 second, right, I receive 4 times 10 to the minus 21 joules, okay?
Yep.
Each photon is 5.57 times 10 to the minus 24 joules, okay? So if I want to know how many of these I need to get to do that, what's the math?
It's...
You can kind of cheat.
I mean, yeah, because I kind of already have the work done.
No. I mean, you can cheat knowing what the answer needs to be. Like, first of all, does the answer need to be a fraction, or does it need to be a number greater than 1?
A number.
It needs to be a number greater than 1, right? You don't want like fractions of a photon.
Yeah. Yeah, exactly.
So, yeah, what are you gonna do? It's okay if you don't know. I can explain it too.
I mean, the higher number would be on the numerator, right?
Nice.
Yeah.
Smaller number.
This is the higher number, by the way, because it's negative 21. I know the exponent is lower because it's 21, but it's negative 21.
Yeah, exactly.
So 4.10 times 10 to the negative 21 all over 5.57 times 10 to the minus 24. Okay.
Wait, is it 4.1 or is it 4.0?
Oh, sorry. Is it 4.0? It is 4.0. I don't know why the fuck I wrote 4.1. I need to eat more salami. Okay, cool. So, if I do 4, right, e to the minus 21, divided by this, that gets me 718. Or 719, basically.
Yeah.
Okay? And then if you want, again, if you want to, like, be fancy with the units, I know that this is the number of photons per second, right? Because in 1 second I receive, so this is technically joules per second, and then this is technically
photons per second.
Photons per second. No. This is joules per photon. Joules per photon. Right?
Damn.
Because each photon is this many joules. So I say 5.57 joules per photon.
Yep.
Okay, now, and look what happens when you divide, right? Joules goes away because it's on the top and the bottom. And then I'm doing 1 over seconds divided by 1 over photons. Remember when we do the flip it
over seconds?
It's photons per second. Yeah. That's the math way that this works. But I like to think of it intuitively of like, okay, but what the fuck does this actually mean?
Okay. Yeah, I definitely did not think of that when I was doing this problem. I literally went to my RA who took this class last year. And he was having a hard time doing it, and we ended up doing it wrong. And then I ended up getting the answer key, and we figured it out. So.
Yeah, it's all good. Yeah, this is a classic physics problem I like to do. But, like I was saying with Demented earlier, the important thing is not to memorize the process. Don't memorize the equation. Don't memorize how to do it. Because they'll switch like one fucking word on here, and you'll have to do it completely differently. You want to understand like the meat, like why is this? Like why am I doing this? Yeah. So, does that make more sense?
Yerp.
Yep. Cool. Nice. I'll send you a screenshot of this. And feel free to ask more questions. Do you have any more questions about this problem? If you have more questions in general, it's okay. I'll get to them. Let me just like run through kids and stuff. But do you have anything more about this that doesn't make sense?
No, not about this. This is like probably like one of the tougher questions I've ever been asked. Just like regarding like this, like area of the topic we've been learning about. So.
Okay. Cool. Well, yeah. Hang around if you want more help with stuff. Otherwise, I sent you the screenshot. Oh, I need to give all you guys bond coins. You guys asked good questions today. Wow. I love that. Nice. Love that. Does this time work for you, by the way, Patty, for like help? Is this like a good time? I'm trying to figure out my schedule for the week.
Well, for now, for now, like, it's a pretty good time because I end classes like around 3 o'clock and then I eat around 5. So now is kind of like, you know, the chill time.
The chill time. Yeah, I used to do that. I'd go to the lunch hall. I'd go stuff my face fucking silly because it was a buffet. R.I.P. freshman 15, dude. I got so fat my freshman year just eating all the free cookies.
Oh god.
But then I would go to the library and I'd go to sleep. What about the cookies?
They're good. They're really good, but I try to avoid them.
Yeah, they're bad, dude. My one homeboy would bring like a Ziploc bag down to the mess hall. Just start like, just start.
We're able to get to-go boxes in my dining hall, so kids will like literally take a whole course meal with them to their room.
Oh my god, college is beautiful, dude. It's beautiful. All right, let me see. Is Equity here? Let me see if I can help Equity out. Otherwise, Demented, I'll keep helping you out with stuff. Or Cuber. Where's Cuber? Let me see. Let me see if he's in the chat. He is Bob Ross's. Still need help. Or at Cuber. Oh man. Are you guys doing anything fun for the weekend, college boys? No. My weekends were always like super fun. If I'm ready, I'm ready. All right, cool. Let's do it. All right, let's do it. Let's do it. Dude. Let's do it. Cuber. Where's your question? Yeah, nice. Let me get him up here. Get the boy up here. What up, Cubes?
Yo.
Yo. Are we doing more matrixy stuff? I can hear you, dude. Oh,
yeah.
I see.
Yeah.
Oh, you sent it to me. I see it. I see it right here, dude. Nice. I like this. I'm surprised y'all are doing augmented matrices in ninth. You're in ninth grade, right? You just started high school?
Oh, yeah.
Yeah, that's pretty rough. I remember, like, last year, your questions were like, here's the number of the day. Like, how would I add this number to something? Or how would I multiply it? And then,
yeah,
like...
that was pretty easy.
I feel like that shit was, like, real easy. And then, like, they just ratcheted up the difficulty this year. I guess you are taking Math 1 honors, though. That's cool. Good for you, man, dude. I know earlier...
I heard the other class is, like, really easy.
I'm glad you're challenging yourself, though. I mean, that's a good thing, Cuber. You know, and I know earlier in the year you were kind of doubting. You're like, I don't know if I can do this, blah, 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 blah. And I always like to say, like, you'll rise to the challenge, man. Like, you'll get it. You just gotta grind.
He gives, like, the whole packet of homework, though, so I just, like, start doing it in advance. So, like, this is, like, he didn't even assign this yet, but I'm just doing it, like, in
Well,
advance.
fuck yeah, dude. Yeah. That is gonna help you out so much, dude. But yeah, looking ahead, yeah, because otherwise you see it and you're like, fuck, I don't know how this works. Okay, what's the question with this though? Well, yeah, so even more power to you for being self-disciplined enough to do this. But yeah, what's the question? What are they asking here?
It's supposed to be a matrix that's showing the system of equations, and we're
Correct.
supposed to solve it using, like, row form or something.
Oh,
row reduction.
Row reduced echelon form. Yeah. Okay. Yeah. No, I got you. Yeah. Do you know what this would convert out to if you were to write it as a systems of equations?
7x plus 2y equals 24.
Nice. Good. Yeah, you know the rest of it. Cool. Awesome. Yeah. Exactly. Yeah. That's what this gets down to. Okay. So row reduced echelon form means that I want to turn this part here into what's called a diagonal unit matrix, which means I want it to be this. I want it to be 1, 0, 0, 1. Okay?
Yeah.
If this was a 3x4, for instance, like, let's say it was
does it always have to, like, the first column is, like,
and then it's like something.
Like the first column always has to be the ets, or
always has to be 1?
Sometimes I, like... Yeah, because sometimes I solve it out, like in a different column. Like, solve ets in a different column than the first.
Yeah, I mean, you can. You're talking about here. Well, okay, so here's what it is. Whatever this index is going to be the same thing. So if this is X, this has to be X. If this is Y, then this has to be Y. So as long as you're consistent, sure, you could call this Y, you could call this X. You just have to remember when you get to this, you could call this Y, you could call this X. You just have to remember when you get to this, that this refers then to Y and this refers to X.
Oh,
but,
like, what I mean is, like, if it's, like, 0, 1, and then 1, 0.
Oh.
And ets is in the second row.
You mean,
like,
yeah, second row, you mean. Yeah. Yeah, technically this still works, right? Because you still know that 0x plus 1y is equal to something, right? So you know that y is equal to this. That's cool. And then you know that, okay, this one is x is equal to something. But I don't know. It depends, like, how much of a bitch your teacher is. But they just do it in this form. Like,
yeah, because it's sometimes, like, I don't know how to do it, so I just, like, end up, like, it ends up, like, in, like, different areas.
if it ends up in different areas, you know you can just move it around, right?
Yeah, but like, I also have to like explain what I just did, so.
Oh, well, you can get to here, and then you can just say, I'm literally just going to swap these rows. That's all you can say. You just say, I'm swapping them. And then it becomes 1, 0, 0, 1, whatever. Okay? Yeah, just swap them at the end if you want to. But there is a methodology for this, because this gets trickier when you start doing three variable things, which would be like this. Then you eventually need this.
Yeah, we've done some 3 variables.
You've done some 3s? Already. One sec, I gotta reload this. It's mad at me. I've been teaching for too long today.
These are like weird numbers though, so I don't really know how to solve it. Because I don't want to like do too much fractions.
Yeah, you're right. Yeah, the fractions start sucking. But and then it becomes this, like 0, 1, 0, 0, 1, right? And then it's this. Sorry, 1.
Yeah.
And then it's this, right? Da 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 da. Okay. Yeah, so this is called diagonalizing a matrix. So when you're taking something that isn't diagonalized and then turning it into a diagonal matrix, there's a process to it. And the way you want to, it's called, you want to do it, it's called like the snake. You want to start up here, and you want to do like this. Like, you want to try to make this 1 first, then make this 0, then make this 0. Then you want to try to make this 0, make this 1, make this 0. Then you want to try to make this 0, then make this 0, and then make this 1. It's, I forget there's a name for it. There's a name for this method. But it's the most efficient way to diagonalize a matrix, and it's what computers use, I think. I think it's called the snake.
I heard you could like multiply like diagonally in like the matrices.
Yeah, there's another,
like,
yeah.
He wants us to do like row reduction.
Yeah, so the other way to do this is with inverse matrices. Which, have you learned how to invert a matrix yet?
What does that mean?
So you'll see this, like if this is a matrix equals something like this, like blah 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 blah. Then there's also the inverse matrix, which ends up being something different. It's okay if you haven't seen it yet. So. You have, yeah, it's okay. Okay. That's the next step for how to solve these things. And I can actually show it to you how it works if you want. It's actually pretty cool. All right, so the first thing you want to do is you want to try to make this column 1, 0, something, okay? But you want to attack this one first, right? So the easiest way, right, to make this thing 1 would be to do this row minus this row, right? And then replace it with that.
Yeah.
Okay.
So it would be
So let's call this row 1, row 2. So I think how you usually write this is you say row 2 minus row 1 becomes row 1.
Yeah.
All right. So what would it be, Cuber? Then what would we get?
-1.
No. 8 minus 7 would be 1. Right?
Oh yeah, so 1.
We're taking row 2 and we're subtracting row 1 from it, right? So 8 minus 7 is 1. Yeah.
Wait. So we can just like flip row 2 onto row 1?
Yeah. Yeah, if you do math with it, you can, yeah.
Okay. And then 21.
And then 21. Yeah, good. Uh-huh. And then what? Positive 6. Because it's this minus this.
6.
Okay,
Yeah.
and then good. Now we have 8, 23, 30. Okay? Cool. All right, so we made this 1, all right? These are called row operations, is what these are called. And you asked a good question. You're like, wait, can I just subtract these 2 and just reinsert it somewhere else? Yeah, you totally can. You can multiply a row by anything. You can add 2 rows together, or you can subtract 2 rows together. Dividing rows doesn't really work. What's up, Equity? Yeah, cool. Equity, I'll do your question next. Sorry, Cuber jumped in. Okay, so now that this is 1, what's the next step? What's the next thing I'm trying to like turn something into? Let's remember the snake.
Would we try to get rid of the y?
We're trying to get rid of. So look, we did this one first. We got this equal to 1. Like, good job, guys. Right? The next step is to try to make this bottom thing 0. Okay. How can I
So
try
we
to
would
make this bottom thing
We
0?
would multiply the top row by 8.
Mm-hmm.
Then
Top
minus it.
row by what?
8, and then minus it by
Good.
row 2.
Yeah, so you can say 8 times row 1 minus row 2 goes to row 2. Does that make sense?
Yeah.
The other way to say that is to multiply this by -8 and then add them, but this is totally okay. All right. So let's see what we would get for numbers then, Cuber, right? Okay. So this is going to stay as 121.6. But now my row down here is going to be something different. What's going to happen? So it may help you. It may help you, Cuber, to multiply this by 8 just to see what it would be, right?
Yeah,
so if we multiply it by 8, right? This is 8, 168, and then 40.
140, 145.
I think just 40.
0, 145. 0, 145 minus 18.
Oh, okay. I see. You already did it. Okay, so 0, 40. I think it's 47. Oh wait, no, 45. You're right. Sorry. I'm doing this minus this. That's wrong. Sorry, it's this minus this. Yes, good. Okay. 145. Okay, good. And then
negative 145.
No. Because it's 168 minus 23.
Oh yeah. Okay.
Remember, it's 8
That's
times
40.
the first column, which is 168, minus 23, which is 145. Okay. And then what's the next one?
18.
Good. Very good. Okay, cool. All right, so now we're even closer. So here, let me move it over here. So now I have 1, 21, 0, 145, 6, 18. Okay?
Yeah.
What's the next thing I have to do in the snake?
We can divide the row 2, right?
So yes. So
Divided by...
well, not quite. Okay, so remember, this is 1. This is 0.
Yeah.
Good. Yeah, right. Yeah, the next thing is to get this equal to 1, right? And this is easy, right? Yeah, we know how to get this equal to 1. Yeah, you said it. What do we do? We divide it by something, right?
It would be by 18, right? Or...
No, because I want this to be 1. So I'm going to take...
145. So
yeah, good. I'm going to take row 2. I'm going to divide by 145, and that's going to go back into being row 2. I think your teacher usually wants this. They usually want you to show, like, what operations you're doing. Also, just to help you get, like, extra credit or partial credit, right? Otherwise, your teacher is going to be, like, seeing these numbers and be like, what the hell is this guy doing?
Yeah.
Okay, so now...
I think he only needs sound like tests.
Sure.
Like,
yeah,
not
probably
on homework, though.
Yeah, not on homework. I also do this just to, like, keep myself, like, straight. Otherwise, I get confused, like, with what's going on. So 0 divided by 145, right? That's just 0. 145 that's just 1. And then this is 18 over 145. Okay, this is where the nasty fractions come in, yeah?
Yeah.
Okay. All right, then, so now, right, we've got this. Next step is to get this one. How do we get that one out?
Multiply 21 by 18.
Good. So what you're going to say 21 times row 2, right? And I would really say negative 21. I would say negative 21 times row 2. I'm going to add that to row 1, and then that's going to become the new row 1. Do you want to see why that is?
Wait. Negative 21
times row 2.
Row 2.
So that's 0, negative 21. This number fucking sucks. Where's my calculator? 1 sec. This is the problem, is that, like, eventually the numbers get fucking nasty, dude.
378.
Oh, it's 378? Okay. So then it's negative 378 over 145, right? Okay. And then I'm going to take this, my new row 2 that I multiplied, and I'm going to add it to this one. So the 0 isn't going to change this, but you see how the negative 21 is going to kill this thing off?
Oh, yeah.
Okay.
We could also just
We could have also done this
Multiply.
minus this one. What were you gonna say?
Yeah.
Also, what were you gonna say as well?
Yeah, we just multiplied first instead of doing negatives.
Yeah, you could have multiplied and then subtracted 1 from 2.
Yeah.
You want to get in the habit, though, of not really subtracting rows from each other, because it gets complicated which row comes first. Like, am I subtracting the first row from the second or the second row from the first, right? But if you're strictly adding rows, the order doesn't matter, right? If I add this to this, that's the same thing as adding this to this. That's why you want to get in the habit of making things negative and then just adding them to each other to kill them off. Okay?
Okay.
Just a little tip. Make it easy for you. Okay. Well, whatever. Okay, so now this is 1, 0. And then this fucking ugly ham beast of a number. Jesus, dude, what is this? So that's negative 378 divided by 145 plus 6. So that's 3.39. Okay.
Yeah.
And then this stays the same, right? This is 0, 1, 18 over 145. Let's just get that. Which is equal to 0.124. Okay? Now, this is diagonal, so you know your answers, right? Like, what thing is x?
So S would equal 3.39 and Y would equal 0.124.
Nice. Nice.
Can you like screenshot everything? So
I'm gonna send everything to you, dude. Don't worry. But here, I'm gonna show you a trick of how to do this on your. Do you know how to do this on your calculator? Do you have one of these?
Calculator or no?
Oh, you don't have like one of these TI-84s?
I think
No?
I can borrow one though.
Okay.
From, like the school.
Let me show you how easy it is to do it with a calculator. Okay. So all you do here is you just create this matrix, which in this case is a 2 by 3.
The teacher was like showing us how to do it.
Yeah, watch. 7, 2. I'm gonna show you right now. It's 24, 8, 23, 30. Okay. That's your new matrix.
How does it know that it's How does it know that's a system of equations?
Because this is just a regular 2 by 3 matrix. That's what we did. We took a systems of equations and we represented it as a matrix. The matrix doesn't know what the fuck it is. It doesn't care. But it knows how to do math on a matrix to make this left side a diagonal and leave this right side as numbers. And it just so happens in math land that corresponds to the solutions for systems of equations. Like this process of what we did, Cuber, like diagonalizing just like that left-hand part, is a process that a computer can just learn how to do, and it doesn't know why it's doing it. But when it does it, we know that represents the solutions to a systems of equations.
Yeah, wait, so what does the calculator say the answers?
So watch, yeah. So if I go to second matrix, and then I do math on this, this is called RREF, row reduced echelon form. And I do this on matrix A, okay? It's going to give us the same answers. Do you see here? 1, 0, 3.39, 0, 1.124.
Uh-huh.
Yeah. Uh-huh. Yeah. So that's how you can check it. Yeah. It's super cool. Does it make more sense?
Yeah.
All right, cool. Let me give you the screenshot for this. And yeah, please, yeah, come by, dude. Like, I went to the gym before this. I got my pump on, but like after the gym, come by if you want help with your math class, dude. Cause
I think I can come on Wednesday.
Okay, perfect. All right, yeah, Wednesday.
Like, wait, what time like do you end stream on like Tuesday and Monday?
Tuesday, I usually go. So what time zone are you? East Coast or West Coast? I forget.
I'm on West Coast.
Okay, so Tuesdays I go usually 4 to 6. Wednesdays 5 to 7, and then Mondays are 3 to 5. Yeah, so it's like 3. It's usually 2 hours long, and it goes 3, 4, 5 from Monday, Tuesday, Wednesday.
Oh, so was today like a longer day?
Well,
Did you
it's
start later?
No, it's 6:30, so I'm going 5 to 7 today.
Oh wait, so what time is Tuesdays?
4 to 6.
Oh, okay.
So yeah, it can go longer. It's just like I usually get tired after 2 hours, or there aren't people here. If there are people and they keep asking questions and I don't have to teach someone afterwards, I'll keep it running for 3 hours. So yeah, if you get home and you see that I'm still online, yeah, feel free. You can bug me. Like I don't have hard cuts on things unless I have to teach.
I'm also able to just like type in chat, right?
Yeah, of course. Yeah. You don't have
I can like go to the library and just like, but I can't talk there.
Yeah, no, it's obviously it helps a little bit more if you can talk because I can figure out pretty quickly whether you understand something or not just by the tone of your voice. I can be like, no, he doesn't get it.
Yeah.
But yeah, you can. Some students do also just text. So if that's what you have, this is super high res. Okay, yeah, there you go. There's the file. That should help you out. Feel free, come by the streams, get points, get help. Yeah.
Yeah.
Nice.
That's dope.
Yeah.
Okay. Equity, what's up? Where you at, Equity? Else I'm gonna go do more stuff with Demented. Where was Equity's question, sorry, by the way? Where was it? Not this. This was it. Yes. Yes. F of x equals this. G of x equals this. Ooh. Making it a little spicy. Yeah, they're changing the width of it. Okay. I'll give Equity I'll give him 60 seconds. I need some water. Alright, let's see if Demented still wants more help. I think we were learning about... let's kill all these. What was this? Converting numbers to signed decimals. We did that. Decimal to BCD. Alright, let's see what this is. Oh, there's Equity. Equity, what's up? You want help? This is your question. There he is. Yo, 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 yo. Okay. What's up? Good. This is function transformations, I guess is what this is. So they're saying that, f of x, right, is absolute value of x, and then this is something slightly different that is scaled. Okay. And we can think of the scaling in two ways. So it's like shrinking horizontally. So I could say like horizontal shrink. Or I could also say that it's a vertical stretch. I mean, technically, there's a couple ways to do it, right? So if you have something like this, right? You can either stretch it vertically to make it look thinner, or you can compress it, shrink it horizontally to make it look thinner. They both work in these types of curves. And the way to do that is to put a number in front of here, is what it is, right? So we got to figure out what the number needs to be. If it's outside the X, that's the vertical stretching or whatnot. And if it's inside the X, is the horizontal. Oh, what's up, Demented?
Oh, sorry.
No, you're good. Give me. I just need 20 seconds to finish this question. Then, if you still want
Take your
help,
time. Don't worry. Yeah,
Okay,
yeah,
cool.
take your time.
all right, cool. You're good. You're good. You could just write a piecewise function for g of x and call it the answer. I guess you could, Zach. You're right. But anyway, so what I know is that g of x has to be equal to, I don't know, I'm going to say like a times f of x. It's like there's some factor here. There's some factor. And the way to Zach's piecewise means we would break it up into the equation of the line here and the equation of the line here. So piecewise would be like so this looks like, so I would say f of x is equal to, and I would say negative x, and then I would say this is for x is less than or equal to 0, and then I would say it's positive x for x is greater than 0. This is called a piecewise function. So it looks like the line negative x, but only for the negative x values, and it looks like y equals positive x, but only for the positive x values. Yeah, that's a piecewise function. But in reality, so notice this graph is not shifting vertically or horizontally, right? It's not moving up or down. It's not moving left or right. So we don't have to do any shifts. We just have to do shrinks or stretches. And the way to do that is to multiply by some number. So what I'm going to do is try to find another number. I'm going to try to find a place where the lines intersect some nice value of y. So here, for instance, this is going to be 3, 4, whereas this thing was 3, 3. And this makes sense for the blue graph, right? Because if the blue graph is f of x is equal to the absolute value of x, right? Then 3, 3 makes sense. Because if I plug 3 into here, I also get 3 out. Yep. But now for g of x, that needs to be equal to some multiplier. We're going to call this thing a times the original f of x, which is just this. So what I'm going to do is I'm just going to plug in a point. So I know that g of x, which is the y value, that's equal to 4 when x is equal to 3. All right? So 4 is equal to a times 3. You can solve for a now. That just tells me a is equal to 4/3. So the equation for g of x is just that g of x is equal to 4/3 absolute value of x. Does that make sense? And you should kind of see that, right? Because this is a number greater than 1. So all it's doing is it's taking this thing and it's stretching it up, which is, yeah, making it thinner. That's what I was describing about this, right? If you have something like this, if you want to make it thinner, you can either pull it up or you can squish it in. Both work. Yeah. It's actually kind of cool because I could multiply this in as well. This would be the same thing as the absolute value of 4/3 x. So in this way, it's a vertical stretch. And in this way, it's a horizontal shrink. You have to remember that with these transformations, vertical things, right? If it's greater than 1, it's bigger. But with horizontal things, if it's a fraction, if it's less than 1, then it's bigger. So it works both ways. Cool. All right. I hope that helps. Let me know if you need a screenshot. I'll get it to you, Equity. Did your buddy get the keyboard I sent them? Oh shit! I also need to do the SAT awards. Oh, ooh. Let me do that next week. I forgot about that. I want to make a big announcement for it. Do you think so? Okay, good, nice. Yeah, the guy that won the PS5 kind of just gave up. So we have another PS5 to give out. So I'm gonna do that during the fall. I'll just give out another PS5.
No, I'm gonna need that. Yeah, I'm gonna need that PS5.
I know. Did you see they released the new PS5 Pro?
Yeah, I was so mad. I was like, oh yeah.
Fucking sucks, dude. Like, man. I wanted to show Zach my homework apartment set before submitting it, but I got scared. Why'd you get scared? Don't get scared. Zach's great. Yeah, this is garbage, dude. It's $700, and all it does is just increase the graphics, and it doesn't even have a disk drive. No. Like, what? What the hell? And the main thing they're touting off this, by the way, is they're saying that it'll up... It plays games in 4K, yeah, sure. But it says... So the new PS5 Pro will... it'll apparently upscale old games, right? So it'll make them look better. Make old games look better using AI, whatever the fuck. But the issue is that you need a disk drive to play the old games. And it doesn't come with a disk drive. I don't know. Imagine saying you're like, hey, yo, I have these really awesome running shoes that will make you run faster, but they don't come with laces. So like, you're like, what? Well, but how am I gonna run faster if I don't have laces? Yeah. Anyways. Oh, is Penn streaming right now? Penn is streaming. Okay, cool. We'll hop on Penn's streaming a bit. You can, but I feel like the old games are all on discs. Unless maybe we're talking about you can download your old games. Can you? Maybe. That'd be pretty cool. All right. All right. Let's see. Demented. What was the last thing we were doing? Oh, BCD. The fuck is BCD?
Yeah,
What's BCD?
Binomial? Or was it some bullshit like that? Coded decimal.
Okay. I've never heard of this. Let's ask ChatGPT.
Yeah.
Solve this. Just do it.
Let me see if I can remember it before ChatGPT fucks me.
Yeah. Come on,
I'm
chat.
better.
There you go. Let's convert the decimal rules. Okay.
Binary coded decimal. Boom.
There you go. Ooh, okay. Okay.
Like that.
Oh. Okay.
Oh,
So
like
if
you separate it?
yeah, you just separate it and you convert each number to its number. That's easy.
Oh, okay,
right?
that's easy. Yeah, I don't.
Yeah, that's super simple, right? Right. So this is 2 numbers, and then this would be 3 numbers, right?
Yeah.
So that'd be like that. What would this be? This would be 5, right? Because this is the 8.
Yeah.
5, 4,
Okay.
3. 543.
543. Okay.
Right? And then, yeah. With this, you'd have to separate out to 2. Okay, that's cool. Whatever. Convert the following to ASCII? Ew.
The ASCII, I have no clue about either.
You have to look up the ASCII codes.
Oh, if you scroll down, I think it shows it, but it was such a long... No, it doesn't show.
No. The ASCII codes they're really lengthy.
Yeah, because
If you want to look up, like, ASCII code... Yeah, this is what they are.
Yeah, that's what I
like
seen.
this.
I saw like that long shells.
Yeah, it's like this. Yeah, this shit sucks. You don't want to do this. No, we don't want to do this. Here. Okay. Yeah, so you have to look this up on a table. So ASCII value for 2 is 50. ASCII value for D is 68. ASCII for exclamation point is 33. And then you just have to write these, I guess.
My issue is, he said we only get a pen and paper on the test and not a calculator.
You need a table. You need a table for this for sure.
Okay, so hopefully he gives
Yeah,
me a fucking table.
no. You're not gonna memorize the ASCII values.
I would have cried.
No, that would suck, dude. What? No. Okay, cool. All right. No, you don't need to memorize the ASCII table, Zach. Dude, that'd be terrible. Okay. There you go. The binary system is the base 2 system and has a radix. The fuck is a radix?
It's the same as base. It'd be like
so
base
just
of 2 with a radix of 2.
Oh, Zach's like radix. Here, I'm just gonna have ChatGPT do all these.
Don't worry, I solved all of them. That part was easy.
Oh, you did? Okay, this part was easy. I just want to know for myself. Again, like to me at this point, like ChatGPT is just a better Google. I could Google what a radix is, but it's just gonna tell me anyways. The most significant bit is the sign bit. Cool. So that's the first number, right? That's the MSB. And least significant bit must be the last one, right? The number system with base radix is called decimal, right? Yeah. Cool. Binary coded decimal. Cool. Alphanumeric codes. And yes, ASCII is the American Standard Code for Information Interchange. Nice. Awesome. Okay. Does that help you out with your homework, dog? Yeah?
Yes. So much more helpful than my 98-year-old teacher.
I'm glad.
One foot in the grave, yet still teaching. I wish I had that willpower.
Yeah, well, I always say that, like, you know, the only reason we die, besides, like, other reasons, like diseases and, like, fireballs and, like, crazy accidents, is that we're no longer useful on Earth. I think when the human body realizes that it's no longer needed and it's just taking up space, then it's like, okay, time to start shutting down the organs. So I applaud your teacher for still trying to teach, because he's still trying to stay relevant.
Yeah.
He could just be playing golf and saying fuck off to everyone and just like being like, I'm gonna enjoy my life.
Oh yeah, most definitely.
But I feel like the people that do that end up digging their own grave a little quicker, because the body doesn't care if you're playing golf. The body's like, yo, are you doing anything useful? No? Okay. Time to stop taking up oxygen.
Why'd they get rid of Stanley then? I miss him so much.
Stanley.
Those cameos were priceless.
Yeah, but then there's also random things that take people, so whatever.
Yeah.
Okay, cool. All good? Yeah? I think that's all the questions for today. I don't think we have any more questions. So, and we've been streaming for hour 47. That's a good amount of time. Cool. All right, let me close the stream off. All right, thank you everyone for coming to Office Hours. Really appreciate all the questions. It was really awesome to see all you guys, a lot of former students, you know, coming back into the server now that they're in college. That really, it makes me feel good, because I'm like, yes, you guys got into college. Yay, good job.
Nice.
All thanks to you, I swear.
Well, I appreciate that, and I appreciate that, like, you're having a great time, and I hope that's some motivation for the younger students in our server, the ones that are just starting high school and stuff, to know why it's a good idea to start doing well in your classes now, because college is dope. It's so much fun.
Oh my god, I wish I did better. I would have gotten to the more fun stuff.
Yeah, it's okay.
Join sport, do sports. I swear, sports are so much fun in college. From the looks of it, you get to travel the world. It's no longer just like, oh, go here to this. Like,
you'll be in the esports team soon. You'll be on the esports team soon.
Oh right? Yeah, I get to travel the world. Woo!
Maybe we'll see you down here at the LCS system, the whatever thing. That'll be kind of fun.
That'd be fun.
Okay, cool. All right, our next stream. Oh, we don't have it's Wednesday. Oh, nice. Okay, we're done with streams for the week. I usually would have a Golden Hour AMA guest on Friday, but I have to go DJ an event, a club. I got like an opening slot in Houston, so I have to go do that this weekend.
Texas.
Houston, Texas. Yeah, it's where I'm from. Yeah, one of our good friends, his girlfriend of 4 years like cheated on him or something, so he's like, fuck it. Yeah, I know, it's the worst, dude. And he was supposed to go to the Bahamas with her this weekend, so instead of going to the Bahamas, he's coming to Houston. And so then my other friend bought me flights to come in to celebrate, and then got me an opening set at a club. So I'm DJing at a pretty big club for all the boys, and we're gonna have a great time. So I'm looking forward to it. Yeah, you'll see it on Insta. Yeah, you see my Instagram, right? You have my Instagrams?
Yeah, I'm always checking them. Always lurking. I've seen some of the ones you've done.
Yeah, you'll see it. It'll be fun. So yeah, other than that, yeah, so otherwise, yeah, so there's no Golden Hour stream on Friday. Monday, we will restart the stream. Well, actually, no, sorry. There won't be a stream on Monday either. Sorry, because I got to fly back Monday. Next stream will be Tuesday. Tuesday stream, and that's going to be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Again, if you guys ever have questions and I'm not streaming, feel free to, you can post them in help screenshots, and I can try to get to them while I'm on the road. Or otherwise, we have an awesome selection of math streamers who can probably help you so here I'll post that here in the. I wonder if this code works here. One sec. Math streamers. There you go, Demented. So Demented, that's a list of the other friends of ours on Twitch that do math streams. So if you just add all of them on Twitch, and if you ever need help and you see one of them is streaming, usually they're doing the same thing we're doing, like free homework help. And it's most of what you're doing, especially computer science, is very math based, and they can just help you out if I'm not streaming, you know.
Of course.
Cool. Okay, awesome. Great. Here, let's go raid someone else on the Twitch. Let's go raid Penn Center. Love Penn Center. He looks like he's learning mechanics, which is very cool. That's the intro physics class for things. But okay. If you want to learn some mechanics, go hop on Twitch and go say hi to Penn Center. You can learn something ahead of time. But okay, awesome. All right. Have a wonderful rest of your Wednesday, wonderful rest of your week. Have an awesome weekend, and I will see you guys on Tuesday. Peace.
Brace yourselves, everyone.
Really? We'll have to consider differential pieces of the rope to solve this problem. Is the last sentence in the text before this problem starts. Okay, I guess we'll just read the solution then. We'll need to consider differential pieces of rope. Oh god, okay. Hello, Dr. Gold. How are you doing? Welcome on in, Raiders. My name is Penn Center. We're trying to learn classical mechanics tonight and failing miserably. LOL, love when physics is like, check the solutions first. Seriously, like, what? We didn't even talk about differential pieces of anything anywhere in this first chapter. What's happening? So consider a small piece of rope that subtends an angle d theta. Small piece of the rope that subtends angle d theta. What's this? Okay, what is this point? What is this? Is this the pole? Like, what are we actually drawing here? That subtends the pole? So we're actually drawing, like, we're actually considering, like, a little piece of rope like this, and drawing its, like, connection to the pole? Like, what are we actually doing here? The pole has center. Wait. A little curved piece of the rope that's tight against the pole. So is this rope? What are these? Or is this the rope? Where's the rope? Is there a VC? Unfortunately, I can't. I don't think I'm gonna be able to do Discord with my VPN running. I can try. Try, but I make no guarantee that anything's gonna work. I'm in study room south in the elements.
Yeah, can you hear me?
Yep.
Okay, yeah, cool. Yeah, so this is yeah, the diagram sucks here. But what's happening is, so that red dot you have there, that's the center of the pole, and then the diameter, the radius of the pole goes out to the arc T. So there's like a circle, right? And so the T there, that's the tension. That's the tension of where it's being applied along like the dowel.
Gotcha. So you're saying this is the rope,
and then like if you keep drawing a circle around it, that's the whole dowel pole. Yeah. Draw a circle of the radius red. Yeah, middle of the pole. Yeah, there you go. Great.
Yeah, I gotcha. And so that'll be the radius of the pole.
Yeah. Again, usually we assume that the rope is hitting at like just at a single point, and we don't consider that there's a this d theta. Like what? No, this is ridiculous. This is a very upper division physics mechanics. Compared to
you should have seen me try to solve question 1. It was terrifying.
Oh man, yeah. I would make.
Yeah. I haven't got to any questions. I'm still just doing the examples in the textbook.
Yeah, this is what we call like upper division mechanics, which usually is called dynamics. So they don't even call it mechanics; they call it dynamics. And it's it may be better to start with like a mechanics level first before you jump straight up to dynamics, because it gets nitpicky with this. You're not allowed to make assumptions anymore.
I don't even know if I was making assumptions to begin with.
Well, the assumption
I don't even know. There's no. I am so confused without.
Yeah, the assumption I would make is that the rope is only touching the dowel at a single point. That's the assumption we usually make, with the rope being tangent to it, right? But if you start getting into like the more nitty gritty of physics, then we start saying, oh, but the rope technically hugs the pole with this subtended angle. Now treat it as if it's an object. There's a normal force. There's opposing tension forces. What is the friction going to be such that you don't slip? You want to figure out like what's the maximum tension you can have on this thing such that it doesn't exceed the amount of static friction that the rope to the pole can provide.
I have no idea what you just said, but I appreciate the sentiment.
Okay, I have to go teach another student, but I hope that helps you out at least a little bit.
Thanks, thanks for jumping in and answering the question.
You're very welcome, dude. All right, good luck.
Oh man, oh my goodness. Okay, so at least we know where the rope is, I guess. So let's keep reading and see what they're talking about here. The pole exerts a small outward normal force. That's our capital M. That makes sense. This normal force exists to balance the inward components of the tension. Okay. These inward components have magnitude T sine d theta over 2. Let's see if we can figure that out. So let's dive into this diagram. I can see why they're talking about this normal force. That we know that's there. We have this d theta, which is the angle